So I'm going to talk about exact values. Last lesson we looked at the unit circle. Now I could give you some tables and you could rote learn them, but I think it's much more important to teach the man to fish rather than give a man a fish. So in this context, I want to teach you how you can remember these values rather than having to rote learn a whole bunch of values on the tables. So last lesson we looked at the unit circle, correct? And tell me just quickly what the unit circle, what's the radius of the unit circle? 1. And y represents sine theta, and x represents, and we can find tan by going, yeah, so tan theta equals y over x, or sine theta over cos theta, correct? We did that last time. We identified that in the first quadrant, x and y are both, so everything's positive, correct? In the second quadrant, y is positive but x is negative, so only what is positive? Only. Sine in the third quadrant, both x and y are negative, which means that only tan. And in the fourth quadrant, x is positive, y is negative, which means that only cos is positive. Sweet? Happy with that? We did that last time. Now, the reason we talked about exact values because there are some values that we need to know or we need to be able to get on our Tech 3 exam. So there's some trig values and trig ratios we need to be able to determine on our own on Tech 3 exams. I'm going to focus on the OR quadrant to start with, and then we'll talk about the other quadrants after that. So there are two triangles you need to know, and I'm going to do them in radians because you need to develop. Ooh, will I do them in radians? Yeah, I'll do them in radians. We'll do them in radians. I'll do them in radians first. See how we go. So that's the first triangle, also known as the 45-degree triangle, because both of these angles are 45. And then my second triangle and these are both right angles. The second triangle is the 30-60 triangle, correct? Because one of these angles is 30, one of these angles is 60. Which angle do you think is 30? Pi 6, the smaller one. You make it smaller by dividing by a bigger number. Now, I'm going to try because we do have to remember something. We can't just not rote learn something. We have to rote learn a few things here. But this will help us remember for every value. The smallest side on all of these triangles is 1. So can you please write 1 under the smallest side on both of these triangles? That's the first thing we need to rote learn. So a smaller side is 1, which means that on this triangle, that's 1, correct? And on this triangle, they're both 1. Cool. We're at the point we can do this one, but I want to talk about our second thing. We need to remember Pythagoras. And what's Pythagoras again for those of us who potentially don't remember the last 2 years of our life? C squared equals? Yep. Which means that C really equals the square root of those two together, correct? Now the reason we're focusing on C here is because I want to get this number here. What's 1 squared? What's 1 squared plus 1 squared? 2, which means the hypotenuse of that will be root 2. We've just developed the 45-degree triangle. Now the second thing that you need to remember, or third thing, sorry, there's always a 2 on the hypotenuse. Now this one can't be root 2, can it? Because we know that this side's got to be greater than 1. So I'm going to make this just equal to. And you have to remember that. There's always a 2 on the hypotenuse of both triangles. This one's root 2, this one's just 2 by itself. And then we're going to reverse Pythagoras. And now instead of looking for C, what are we looking for? How many sides is this triangle do I know? I know 2 of this one, correct? Yeah, I know 3 for this one, I know 2 for this one, correct? How do I find the third side? Rearrange Pythagoras. So for this one, it would be c squared minus a squared equals b squared, or b equals c squared minus a squared. What's 2 squared? Minus 1 squared. What's the last side of our triangle? Cool. So that's how we remember our... We already know Pythagoras, correct? That makes sense. We get why we make that 1, the smaller side's 1. The only thing we've really got to remember is this. So we've got to remember one thing. There's always a 2 in the hypotenuse. And use a bit of logic. So just trust me when if you were to ask my Year 12s, and I recommend you do, talk to the Year 12s about what they sort of wish they engaged in, really made sure they locked down when they were in Year 11. I'd say this would feature in the top 3. So make sure you're really on top of your exact values and understanding these triangles. Now, I've left those in radians. Now, I could change these angles and then what colour could I? I'll just, if you feel that you absolutely can't do with radians right now, I don't want you missing out on this. So they're both 45-degree angles. And this angle here is 60 degrees, and this angle here is 30 degrees. Now, by the end of this whole exposure, you'll be at the point where you can deal with a number of angles outside of 30, 45 and 60. You'll also be able to deal with 0, 90 degrees, 120, 135, 150, 240, 180, 210. You get the idea, right? Every multiple thing on that. We'll talk about that in a second. I'll put a bow on that one, and then we can go to exercise, I think it's 8.2, question 1. Just start with that, and then I will come back to the unit circle